There is a plane so advanced that the U.S. government hid it from the world for over a decade. A plane so fragile that rain, humidity, and even a slight change in temperature can destroy its most critical ability. A plane so expensive that housing it costs more than building an entire neighborhood. And the hangars built to protect it are not just buildings, they are classified, climate-controlled fortresses hidden on restricted land that most Americans will never set foot on. This is the real story of how the U.S. military protects its most valuable flying machines, and why the answer involves secret desert bases, underground facilities, and engineering that rivals the aircraft itself. The B-2 Spirit stealth bomber costs $2.1 billion per aircraft. That is not the cost of the program. That is the cost of a single plane. And the moment it lands, it needs to disappear inside a structure specifically built to keep its stealth coating alive, its electronics stable, and its identity hidden. What goes into protecting a fleet worth over $40 billion total? That answer takes us deep inside some of the most secure real estate on the planet. If you've ever been fascinated by the sheer power and secrecy of U.S. military aviation, type proud in the comments below. This one's for every American who values what these men and women protect from the skies. The story starts at Whiteman Air Force Base in Missouri. This is the official home of the B-2 Spirit, and it is where the 509th Bomb Wing operates. On the surface, it looks like a regular military installation. But the hangars here are unlike anything else in the world. Each one was purpose-built for a single aircraft, not a squadron, not a group, one plane, one hangar. The reason is not just about security, it is about survival. The B-2's stealth capability comes almost entirely from its outer skin. That skin is layered with radar-absorbing materials that are extraordinarily sensitive. Moisture gets in, and the coating starts to break down. Extreme heat causes it to crack. Dust particles embed themselves into the surface and create tiny reflective patches that show up on enemy radar. A single compromised panel can mean the difference between an invisible aircraft and a visible target. So the hangars at Whiteman are not storage spaces. They are precision environments. The temperature inside is controlled to within a very specific range. The humidity is monitored constantly by automated systems. When a B-2 returns from a mission, it does not simply park and power down. A full team of specialists begins inspecting every inch of the outer surface using detailed checklists that can run into the hundreds of steps. Any area where the radar-absorbing coating shows wear, damage, or separation is flagged, recorded, and repaired before the aircraft is cleared for its next flight. That process can take days, sometimes weeks. This is why the U.S. only operates 20 B-2 bombers. Maintaining them is not just expensive, it is an around-the-clock commitment. And here is something that most people never hear about. The doors to these hangars are not regular aircraft hangar doors. They are reinforced, specifically designed to protect against blast pressure from nearby explosions. The hangars themselves are built with structural redundancy, meaning even if part of the structure takes damage, the core of the facility protecting the aircraft remains intact. The ventilation systems inside run continuously, cycling filtered air to prevent any kind of particle contamination. The lighting is engineered to allow maintenance crews to inspect the aircraft's surface without creating hot spots or reflective glare that might mask surface damage. Every single detail has been thought through, because losing even one of these aircraft to poor storage would be a national security failure. Now here is where the story gets even more interesting. Whiteman is the public-facing home of the B-2. But there is another location, one that the U.S. government guarded with absolute secrecy for years, and that location tells us even more about how America has always approached the storage of its most sensitive aircraft. That place is Tonopah Test Range in Nevada, and what was stored there, quietly hidden for over a decade, was the F-117 Nighthawk, the world's first operational stealth aircraft. The F-117 was built in the late 1970s and early 1980s, and for years the U.S. government officially denied it existed. The aircraft flew only at night. Pilots who flew it were not allowed to tell their families what they did. When it landed, it went directly into a hangar, and the doors closed before sunrise. The hangars at Tonopah were designed with this secrecy in mind. Each one had an individual door system, meaning aircraft could be moved in and out without exposing any other aircraft in nearby hangars. The ramp lighting was minimal and carefully directed to avoid visibility from outside the base perimeter. Satellite photography from that era, later declassified, showed the hangars but gave no indication of what was inside. That was intentional. The shape, the spacing, the materials, all of it was chosen to reveal as little as possible. When the F-117 was officially retired in 2008, most people assumed it was gone for good. It was not. Congress made a decision that very few people knew about at the time. They secretly ordered the Air Force to keep the F-117s in what is called flyable storage. That means the aircraft were preserved in a condition where they could be brought back into service if needed. The wings were removed and stored alongside the fuselages. The engines were preserved. The avionics were maintained at a basic functional level. All of this was done at Tonopah, inside the same climate-controlled hangars the aircraft had used during their operational years. And as recently as 2025, F-117s have been spotted flying again over Nevada test ranges, being used as stealthy adversaries in training exercises and radar testing programs. Before we go further, please take a second to like this video and subscribe to the channel. Over 98% of viewers watch without subscribing. It costs you nothing but means everything to this channel. Hit that subscribe button now, and let's keep going. The idea of flyable storage raises a question that is worth sitting with for a moment. Why keep retired aircraft in a condition where they can fly again? The answer says a lot about how the U.S. military thinks about long-term strategic planning. Technology moves fast, but threats move faster. An aircraft that seemed obsolete 5 years ago might carry systems, design features, or stealth characteristics that remain relevant in a new conflict environment. The F-117 may be old, but its angular stealth design still presents challenges for certain radar systems. Its ability to simulate a low observable threat in training gives American pilots and radar operators experience they cannot get any other way. The investment in keeping those aircraft alive and flyable is a fraction of what it would cost to replace that training value with something new. This same logic applies to the storage decisions being made right now about the F-22 Raptor. The Air Force has been working through a plan to retire its oldest F-22 variants, specifically the Block 20 models that were used primarily for training. These aircraft are being sent to the Davis-Monthan Air Force Base in Arizona, home of the Aerospace Maintenance and Regeneration Group, a facility most people know simply as the Boneyard. But storing stealth aircraft at the Boneyard is not the same as storing an old cargo plane or a retired helicopter. The process is completely different. Specialized teams are being trained specifically to handle stealth materials. The preservation process involves running protective oil compounds through the aircraft's fluid systems, sealing off all openings with protective covers, and applying a spray-based latex coating over the cockpit, intakes, and exhaust areas to shield them from the intense Arizona sun and heat. What makes this even more significant is that this is the first time the U.S. has had to figure out large-scale storage and eventual disposal of fifth-generation stealth aircraft. The decisions being made right now about the F-22 will set the precedent for what happens when the B-2 bomber begins to retire around 2030, and eventually when the broader F-22 fleet winds down around the same period. There are genuine legal, environmental, and security concerns involved. Stealth materials contain compounds that are hazardous. Previous incidents involving the burning of stealth materials at classified facilities resulted in serious health consequences for workers, and lawsuits followed. Getting the disposal and storage process right is not just a logistical challenge, it is a legal and moral obligation to the service members involved. Now let's go somewhere that very few cameras have ever pointed toward. Groom Lake, Nevada. Most people know it by another name, Area 51. For decades, this facility has been the testing ground for America's most advanced classified aircraft. The F-117 was tested there. Multiple other programs that have never been officially acknowledged were developed and flown from that location. And today, it remains one of the most active and most secretive aviation facilities on Earth. In August 2025, an aviation photographer captured footage from Tikaboo Peak, the only public vantage point with a distant line of sight to the base, showing an unidentified aircraft departing Groom Lake, performing test maneuvers, and returning to land. The aircraft used a classified call sign and taxied directly into Hangar 18, one of the largest structures on the base. Hangar 18 at Groom Lake is not just large by ordinary standards. It is large enough to accommodate any known U.S. aircraft with room to spare. The speculation about what is stored or tested inside that structure has gone on for years. What is confirmed is that this hangar has been the destination for some of the most sensitive aircraft movements ever recorded by civilian observers. Also operating out of Groom Lake is an aircraft known as the NT-43A, which carries the call sign RAT-55. This is a modified Boeing 737 that has been converted into a radar and infrared signature measurement platform. Its specific job is to fly alongside stealth aircraft and measure their radar cross-section in actual flight conditions, something that ground-based test ranges cannot accurately replicate. When a B-2 comes out of a major maintenance cycle and its stealth coating has been repaired or upgraded, RAT-55 goes up alongside it over the Nevada and California test ranges to verify that the aircraft's radar signature matches the required specifications. Only after that verification is the aircraft cleared for operational use. This is part of why the secret hangar infrastructure matters so much. The entire system, from storage to maintenance to testing, is interconnected. There is one more piece of this story that brings everything together, and it happened just last year. In June 2025, the U.S. military launched Operation Midnight Hammer. 7 B-2 Spirit bombers flew from their hangars at Whiteman Air Force Base, penetrated Iranian airspace, and struck hardened nuclear facilities that no other aircraft could have reached. F-22 Raptors and F-35 fighters flew escort. All aircraft returned safely. Not a single one was detected or engaged by Iranian air defenses. This mission was the most direct real-world demonstration in recent history of why the U.S. invests so heavily in stealth technology and in the infrastructure that keeps these aircraft ready. Those 7 B-2s that flew the mission had been living in their climate-controlled hangars at Whiteman right up until the moment of deployment. Their coatings were inspected, their systems were verified. Every preparation that the secret hangar infrastructure makes possible had been completed before those aircraft ever left the ground. When they hit their targets and turned for home, they did so as fully capable, fully stealthy platforms, because the system designed to keep them that way had worked exactly as intended. The men and women who maintain these aircraft, who work the overnight shifts inspecting coating panels and running humidity checks and calibrating environmental controls, rarely get recognition. They do not fly the missions. Their names are not in the press releases. But without their work, the B-2 is just an expensive flying wing with no special capability. The hangars, the maintenance systems, the storage protocols, all of it exists because of the dedication of American service members and defense workers who take their responsibility seriously every single day. The future of stealth storage is already being planned. The B-21 Raider, the next-generation long-range stealth bomber, is currently in production and will eventually replace the B-2. New hangar facilities are being developed to support the B-21, and early indications suggest they will incorporate even more advanced environmental control technology, along with automated surface inspection systems that use sensors to detect coating degradation faster than human inspectors can. The lessons learned from decades of B-2 maintenance are being built directly into the infrastructure designed for the Raider. At the same time, the F-47, which is the next-generation air dominance fighter currently in development, will require its own specialized storage and maintenance approach once it enters service. Sixth-generation stealth presents new challenges because these aircraft incorporate materials and design features that go well beyond what the B-2 or F-22 require. The facilities being designed for them will likely remain classified for years, just as Tonopah was classified, just as the early B-2 hangars at Whiteman were classified before the program became public knowledge. The pattern has always been the same. America builds something extraordinary. It hides it. It protects it with infrastructure that is just as extraordinary as the aircraft itself. And eventually, that aircraft proves its value in the real world, in a way that justifies every dollar spent on every hangar, every climate control system, and every overnight maintenance shift. A $2 billion aircraft is only worth $2 billion if it can do what it was built to do. And it can only do that if the system around it, the hangars, the storage protocols, the classified facilities, the trained personnel, functions at the same level of excellence as the aircraft itself. That is the real story here. Not just a plane. An entire ecosystem built around protecting America's edge in the sky. If this video gave you a new perspective on what it actually takes to maintain U.S. air superiority, hit the like button right now and subscribe to the channel so you never miss content like this. The next video goes somewhere you will not want to miss.